I don't know what I was thinking when I made the booklet on this page, because there's no way that you can fit those two derivatives via first principles in example 4.2. Sorry about that. So you'll need to write these down in your notebook rather than your booklet. But example 4.2 says use first principles to find the derivative function. So find f dash of x for f of x equals 3x squared plus 2x plus 1. Before we get started, we need to write down f of x plus h, which is 3 outside of x plus h all squared plus 2 x plus h plus 1, which is 3x squared plus 6 hx plus 3h squared plus 2x plus 2h plus 1. From there, we use a rule, write the rule, so f dash of x equals the limit as h approaches 0, f of x plus h minus f of x on h, which is the limit as h approaches 0 of 3x squared plus 6hx plus 3h squared plus 2x plus 2h plus 1 minus our original function, which is 3x squared plus 2x plus 1. Distributing the minus into the bracket is going to give us minus 3x squared minus 2x minus 1. And don't forget that that is all over h. So then the limit as h approaches 0 becomes, and we look at what we can cancel out, 3x squared minus 3x squared plus 2x minus 2x plus 1 minus 1. Remembering that after you have done your cancelling, all of the remaining terms should have an h in them because we need to factorise the h to get rid of it. So I'm going to factorise straight away in this next step. So I'm left with h outside of 6x plus 3h plus 2 all over h. Then I can cancel my h's and I'm left with the limit as h approaches 0 of 6x plus 3h plus 2. That's as simple as I can possibly make it. So now it's time to do the limit instruction, which is to substitute the value into the equation. I do the instruction, which means I don't write the instruction down anymore. So it's 6x plus 3 lots of 0 plus 2, which is simply 6x plus 2. Therefore, f dash of x equals 6x plus 2. And I'll do example 4.2b in the next question. And that will show us how to handle a fraction when we're taking the derivative of a fraction.